Hello, we're group number 43. Our group member are Xingyue Chang, Mahir Hassan, Christian Lan, Ivy Pan, Eric Xue, Julian Yan, and Huaxuan Yu. Vehicles are an essential components of daily life. Since the introduction of the first vehicle in the 20th century, vehicle ownership has seen exponential growth, driven by the population growth and decrease in production cost, making them more accessible to a larger segment of the population.
As a result of increasing vehicle ownership, traffic has become a major challenge in urban areas, leading to a rise in collision and congestion. Despite efforts to reduce the traffic accidents since the 20th century, nearly 1.35 million people globally still lose their lives, according to the research from the CDC. This highlights the ongoing transport safety issue faced by communities around the world.
In addition to safety concerns, the growing number of vehicles on roads contributes to severe traffic congestion. Conventionally, this issue has been addressed by expanding the road network. However, high-density areas are often located near congested roads, making it challenging to build more roadways to address the congestion issue. Today, we will be presenting our thesis. A centralized traffic system is a comprehensive solution to modern-day traffic-related issues.
We will begin by analyzing the traffic safety problems through data. INRX is a private company in the U.S. that specializes in transportation analysis. According to their research, traffic fatalities rates in U.S. will grow 19% higher in 2022 since 2019. The Germany projects a 9% increase in road fatalities during 2022. In Toronto, 60 traffic fatalities occurred, which has increased by 10.5% since 2019. In London, data reveals that there were 73 fatalities and 26,596 injuries, resulting from 23,139 reported traffic crashes. These statistics are limited to just two cities, and one can imagine the overall impact on global scale. Aside from prioritizing safety, it's crucial to consider the impact of traffic delays on time and finances. Data shows Toronto drivers spent 118 hours stuck in traffic last year, an increase of 60% from the previous year. This results in a yearly loss of $3.3 billion in productivity of Canada, along with additional expenses for the fuel. The figure shows the time and the fuel costs are the main economic loss from the traffic congestion, indicating the ongoing transportation problems with a negative impact on the economy.
According to Figure 2, we can see that the traffic problem does not lie only in specific countries or cities. It is already a global problem with significant manifestation in large cities. In an effort to mitigate traffic issues, it is imperative to analyze the root cause. By Figure 3, bottlenecks are the leading cause, accounting for 14%, followed by incident. Manufacturers can be improved or eliminated with proper planning and control. By monitoring roads and optimizing signal division, bottlenecks and poor signal can be improved. This presents a great opportunity for entrepreneurship to solve the ongoing transportation problem globally and benefit countries facing economic damage from transportation issues. Our smart city solution aims to tackle the issue by utilizing innovative technology to control all vehicles. So the government of all nations are potential clients for our products. We anticipate that the government will implement our approach to reduce the number of motor accidents. Therefore, consumer availability is satisfied. With our unique approach, we are poised to gain a competitive advantage in the market as we can be the first to bring this system to the market.
A major cause of traffic delay is the startup loss time, where a driver has to wait to start accelerating after the vehicle in front has moved safely. As shown by research, for the 10th vehicle in queue, it can take 15 to 30 seconds to start accelerating. Considering that green light can last as few as 36 seconds on a major intersection, this heavily reduces the time available for crossing before the lights turn red. This problem even occurs when vehicles are fully stopped, as demonstrated in an experiment where congestion still appeared despite vehicles were ordered to drive as smooth as possible in a circle.
The solution that we're proposing is a centralized traffic system, which have the ability to control and manage vehicles, traffic lights, and all other components of a traffic system through a central network. By monitoring vehicle speed, location, and destination, the system can adjust traffic lights and control other vehicles accordingly to minimize traffic inefficiency and collisions. A centralized traffic system can reduce congestion by enabling synchronous acceleration when lights turn green, saving up to 30 seconds per cycle at intersections with an average queue of 10 cars, as shown by research. This system can also mitigate congestions on roads with long green light times, as congestion can still form even when vehicles are driving normally. This system will also reduce traffic accidents by using automated controls to monitor and control vehicles, reducing human error. If a potential collision is detected, the system can force the two vehicles, as well as other incoming vehicles, to stop, preventing a collision and potential train collisions. Many solutions to traffic issues have been proposed and experimented, but we believe a centralized traffic system is the best one. Here's a decision matrix that helps us evaluate each solution. We evaluate solutions from 6 different aspects, each with different weights based on real-life context. For example, we emphasize the effectiveness because we have demonstrated that this problem is a pressing issue and will only become more severe as the number of vehicles increase. A high weight was also assigned to feasibility, recognizing that the proposed solutions will require significant changes to infrastructure and entail high costs in terms of time and money. Finally, cost, time, and ease of maintenance are not considered as significant factors, as governments have been shown to be willing to invest large sums of money and effort on traffic issues. This is supported by the fact that the US passed the Bipartisan Infrastructure Bill in 2021, providing a $700 billion package to improve highway, transit, and traffic safety. The decision matrix shows that a centralized traffic system will be the best solution for traffic issues around the world.
Before introducing the implementation plan, we will address the potential issues and reflections of the centralized traffic system solution. Technical challenges, such as the robustness of a complex network of sensors and servers, are a concern. However, by anticipating high-risk scenarios like power outages and implementing fail-safes, we can ensure the reliability of the system. The cost of the implementation is another issue, but it can be minimized by implementing the system in stages, and the cost can eventually be offset by the economic benefits resulting from shortened traffic time and lower risk of accidents. Finally, we must consider public resistance and address their concerns through evidence-based communication and testing in a less populated region before full implementation in major cities. To implement a centralized traffic system, a smart city infrastructure is required. Since this is not a simple process, we have devised both short-term and long-term plans. In the beginning, the system can be tested in a less developed city before being rolled out into urban areas. We start by promoting the transition to electric cars because they can be better monitored by computers. We also need to establish regulations to embed network devices into existing and newly manufactured vehicles. We must establish internet with fast and stable connectivity throughout the city to ensure that data are transferred in a timely manner. A robust and flexible software infrastructure with high computing power servers is also needed for real-time data processing. We must build large data lakes to store that vast amount of raw data that comes through the field gateways from vehicles, and create efficient algorithms to extract the necessary data at times of computation. In the long term, the system needs to be integrated into multiple cities to ensure vehicles can travel freely in between them. We also need to continuously perform maintenance and improve the system through machine learning and statistical analytics.
Now the question arises, why on earth should we switch to an autonomous driving system when human control is already sufficient? Well, implementing a perfect artificial intelligence system in the automotive industry imposes a flurry of benefits. Improved safety, efficiency, cost, performance, and customer satisfaction, just to name a few. And not only does this list go on, but this list has already begun to be executed in the workshops of many well-known car companies. Let's go through a few of the benefits I listed. AI can help make vehicles safer by reducing car accidents and improving driver safety. Google's Waymo subsidiary is developing an autonomous driving system that uses deep learning to process data from sensors and cameras. AI can also help improve fuel efficiency by reducing emissions. Nissan is using AI to develop a smart vehicle that can adjust its engine output to match the driving conditions. Finally, AI can help improve vehicle performance by optimizing engine output. BMW is using AI to develop a system that can optimize engine output for differing driving conditions. All in all, these factors contribute to the overall greater efficiency of the transportation system, leading to a more suitable future for urban society.